In this video, we're going to be taking a look at a very famous pathfinding algorithm called Dijkstra's algorithm. This algorithm calculates the shortest path from the blue dot in the top left-hand corner to the yellow dot that I've drawn in. This program not only allows us to determine the endpoint, it also gives us the possibility to draw a wall which obstructs the algorithm. And in this video, we're going to be recreating this visualization using Python and the module Pygame. So let's jump straight in, and if you do end up getting a job at Google because you looked at this tutorial, then make sure to leave a like down below. Alright, now we're going to jump into some code. Over in the editor, I have a couple of lines of code already written, so let me just briefly run this code and show you from what we're going to start. So when I run it, you will see this small black window pop up, and we have the possibility to close the window by pressing this small red X icon. And this is exactly what the code in the editor does. But let me go through this line by line so that we're all on the same page. At the very top, I have a couple of imports. First, I'm importing message box from Dijkstra. This allows us to create small dialog boxes that we're going to be using later on. Then I have another import, and I'm importing Pygame as well as the module systems. Below that, I am creating the window. So I've set the width to 500, the height to 500, and below that I've initialized one of those Pygame displays, and I've passed in the width and the height as the arguments within this function. Below that, I have the main method, and the main method houses our main loop. This is our main loop over here. And the main loop at the moment is still looking kind of empty. All it has is this standard code block. And what this code block allows us to do is basically close the window. You see this small black window that we have. And when I press on this small X, it closes the window, and this is exactly what this block of code does. And below that, we have a window fill, which fills our window with the color black. And finally, we have a display flip method being called, and this basically just updates the display. So many of you might be accustomed to using display update instead of display flip. You can use either one over here. They both will work. And at the very end, I'm calling the main method. The next thing we're going to do is we want to create something that looks like this. So we want to create a grid sort of pattern, and we want to create this grid by filling the black box that we have at the moment with small boxes. And these boxes are going to be identifiable by using a pair of indexes. So the index that goes horizontally is going to be the index called I, and the index going vertically is going to be the index called J. So when we talk about a box with the index 0, 0, we're talking about the one on the top left. And similarly, if we're talking about the box with the index 25, 25, we're talking about this one on the bottom right. So every box in the grid will be uniquely identifiable by a pair of indices. So how do we create something that looks like that? The first thing we're going to do is we're going to create a couple of columns and a couple of rows. We're going to say that we have 25 columns and 25 rows. In addition to that, we need to specify the width and the height of each of these boxes. So we're going to set the width equal to the window width divided by the number of columns, and the height of the box is going to be equal to the window height divided by the number of rows. Once we've done that, we're going to create an empty array, and this empty array is going to be called grid. Now this empty array is going to store all the individual boxes that I showed you in this image. All of these individual boxes are going to be stored in this grid array, but we're going to get to that in just a moment. Once we've done that, we're creating a new class called box, and in it, we're creating a couple of methods. The first one is going to be an init method, and there you can see that we have the two indices that I talked about earlier, the I and the J. So that's how we're going to identify each of these boxes. So we're going to write self.x is I and self.y is j, and this is going to tell us the position of the box. And after that, we are going to create a draw method within this class. Now the draw method is going to help us draw these individual boxes onto our canvas, and it takes a couple of arguments. It takes the window within which we want to draw the boxes, which is going to be the window over here, so we're passing it as an argument in here. And in addition to that, it also takes the color of the box as an argument. So we get this nice visualization effect by taking different colors for different parts of the algorithm, which is going to look really nice. After that, we are going to call the drawRect method from the Pygame module, and in here we're passing in a couple of arguments. First, we're passing in the window where we're drawing the rectangle to, then we're passing in the color of the rectangle, the x coordinate of the rectangle, the y coordinate, as well as the width and the height. Now you'll see that I have subtracted 2 pixels off the width and the height. Why I do that, you'll see that in just a moment. Then I have the final thing that I need to do over here before the main method, and that is actually save all of the instances of the box within this grid array that we created up here. So after we have appended all of these individual boxes, so over here you can see that we are creating instances of the class box, and we're appending it to the array. And after appending it to this array, we are appending the array to the grid array. All right. So now we have filled the grid with all these instances of the class box. The final thing that we need to do in order to draw the grid within our window is we need to call the draw function in the class box on each individual box. So by looping through all the columns and all the rows, we can reference each individual box on the grid and apply the function draw to it. And so now let's go ahead and run this to see what the result of this is. So if I run this, you'll see that I have created this very nice grid. And I think it's going to be a bit dark for you. Let me just change the color to make sure that it looks a bit more clear to you guys on your screen. Yeah, now it looks a little bit better. So as you can see, I've created all these boxes and drawn them all in the color gray. Now what I do still want to explain is why we actually subtracted 2 from the width and the height over here. So let's say that I get rid of this, and you'll see that the border around the box is simply not going to be there anymore, and we simply have this gray plane. So I do need to add some sort of margin around here so that we have this nice grid effect. So that is why I subtracted the 2 pixels from the width and the height. The next thing that we want to be able to do is we want to be able to color the different boxes depending on their function. So back in the paint window, let's say that the top leftmost box should be the starting point. Then we should be able to add a specific color to it. Or let's say that we add a wall to obstruct the algorithm, for instance over here, then these 3 boxes should have another color. And the same thing should apply to the target, so the point where the algorithm should end. So how do we manage to create this color scheme for the different boxes? So back in the editor, the way we're going to do this is we're going to set different flags for the different boxes. Over here I've created one flag for the starting box, one flag for the wall boxes, and one flag for the target box. Let me just briefly go and open the paint window again. So over here, if we have the first box, this one over here, and let's say that this box is the place where the algorithm starts, then this box should have the start flag over here set to true. Similarly, these 3 boxes over here that are going to be making up our wall have the wall flag set to true. And then finally, if we have the endpoint, we are going to have the target flag set to true. So that's what these 3 flags are going to do. Then further below, we're going to set the start box in the top left corner. So exactly like it is in this paint window, this is going to be the start over here. And since this has the index 0, 0, we're passing in the appropriate indexes over here as well. So since this is our start box, we also need to set the flag, and we're setting the start flag to true. Next up, we're going to go down to the main method, and we're going to create a variable that triggers the algorithm. You don't need to worry about that now. We're going to be using this one later on, but at the beginning, it's going to be set to false. And we're going to trigger this variable by pressing a key on our keyboard. So whenever we press, let's say, the space bar and the algorithm starts, then this is going to be set to true. In addition to that, we're also going to set the target box set variable to false, because we'll be able to set the target box, so the box to which the algorithm finds the path, the endpoint, manually with our mouse. So we can't run the algorithm until this variable is set. And so we're going to set it to false over here. And then further below, we are going to create some mouse controls. So when we draw the wall that obstructs the algorithm, we need to capture the mouse position. And this is exactly what we do in this code block. So over here, we are checking for the event type mouse motion. So if we are moving our mouse, then we're going to set the x variable equal to the x position and the y variable equal to the y position on our screen. Subsequently, we can have another small code block that is going to help us draw the wall which obstructs the algorithm. So over here, we're saying that if the event .buttons is 0, so this basically means whenever the left mouse button is pressed, so this is equivalent to the left mouse button being pressed, then we are first going to set the index of the box being selected. So we're going to set the I index and the J index, and we're going to set the wall flag over here of this specific grid item to true. And finally, we are going to then set the target. So the target is basically the point to which the algorithm is going to run. So where the path is going to end. And in order to set this, we're going to say that the right mouse button needs to be pressed. So this event.buttons2 basically means the left mouse button needs to be pressed. And in addition to that, we are going to check if the target box set variable, which we created up here, is set to false. So if we then set the target box variable, we're going to set this variable to true, and then we can't change the target anymore, right? In addition, you can see here that we're setting the appropriate flag, because the target box is going to have the flag target set to true. Okay, and then after that, we are checking for a key press on our keyboard, and this is going to start our algorithm. So whenever the event type is a key down, so whenever we press on the keyboard, and in addition to that, the target box is set, so we can only start the algorithm run whenever the target has been set. So if we don't have an endpoint to the algorithm, then of course we shouldn't be able to run it. So only if these two things apply, a button is pressed and the target box is set, only then do we begin the search. Then further down below, we're going to make sure that the individual boxes are drawn in the right color. So if the start flag is set, we're going to use one color. If the wall flag is set, we're going to use another color. And finally, if the target flag is set, we're going to use a third color. So let's now go ahead and run this. And you'll be able to see that the top left box is colored a little bit differently. It's this light blue color. And that is because the start flag of this box is set to true. This is our starting point. Now watch what happens when I press my left mouse button. You can see that I can drag it around and create walls, which are going to obstruct the algorithm later on. Now when I press my right mouse button, you can see that this yellow box pops up, and this is going to be the endpoint to which the algorithm tries to find the path. All right, so now we have managed to create this this canvas, and we have been able to set the colors of the individual boxes. Now that we've managed to create the grid and also color code the grid depending on the flag that is set for the box, we are now ready to implement the algorithm. Now before I get into that, let me just briefly show you in this diagram that we used earlier how the algorithm is going to work. So we are going to set the top left box as our start point, and then in addition to that, when we left click, we are going to set an endpoint. Let's just pick this one. And for the moment, we're going to leave the walls out. So how is this algorithm going to work? We're going to be creating a queue, and by default, the first queue item is going to be the starting point. And once we've queued this item, we're going to also add its neighboring blocks into the queue. In the case of this initial block, the neighboring blocks are going to be the block over here, as well as the block down here. And let me perhaps use a different color so that we know that these boxes are queued. Now, once they've been queued, the algorithm is going to step over to these individual boxes. So let's say the algorithm visits this box over here. Then once it has visited this block, it is also going to take its neighboring boxes and add them to the queue of boxes that still need to be visited. So then if the algorithm next moves to this box over here, this one turns green, and it takes its neighbors, which is this one, and adds it to the queue. And it goes through these individual blocks, one by one, adding its neighbors and moving to the next block until one of these green boxes goes over and meets with the blue box, which is the end. So over here in this diagram, we have two types of new flags that we'll need to add. One flag is going to take care of the boxes that have already been visited, so that are already green. And the other flag is going to be the boxes that have been added to the queue, but have not yet been visited. So these are red in our diagram over here. So let's go over to our editor and start creating this algorithm logic. So the first thing we want to do is we want to create an empty array called queue that is going to store the boxes in our queue. Then below in the class called box, we want to add the flag queued. And the individual boxes are going to be unqueued by default. So when we start off, none of these boxes are going to be queued. So by default, we're going to set it to false. Similarly, none of the boxes on our grid are going to be visited at the very beginning. And there is one exception to this rule. At the very beginning, our starting box is going to be queued because we need one item in our queue, but we'll get to that later on. After that, we're also going to add another empty array over here where we're going to store the neighbors of each individual box. After that, we need a function that is going to set the individual neighbors of every box. So first, we're going to take care of the horizontal neighbors. And so what's happening in these two lines of code is that we are appending to the neighbors array the individual neighbors of a box. So let me show you guys what that means using our very nice diagram over here. So let's just say, for example, we're talking about this box over here that I've just colored in purple. Let me just make this a little bit bigger. This box that I've colored in purple. Then its horizontal neighbors are the boxes that lie over here and the one over here. So now these two boxes are being appended to the neighbors array. Now, we don't only need the horizontal neighbors, we also need the vertical neighbors, and that's what these two next lines do. So in addition to these green boxes, we're now also taking care of these, let me make this red perhaps, these vertical neighbors of the purple box. And so we're appending not only the red, but also the green boxes to this neighbors array. Now further below, we are going to set the neighbors for every box in our grid. So we're going to be doing this process that I've just drawn out over here. We're going to be doing this process for all the boxes in our grid. Yeah, for all the boxes in our grid. So remember how we have the index I over here and the index j over here? We're going to be iterating through all the I indexes and all the j indexes, and we're going to be setting the neighbors by calling the neighbors function on the individual boxes. All right, once that's done, we are going to set the flag visited to true for our starting box, and we're also going to append the start box to our queue. So this small box at the very beginning that I talked about, our starting point, yeah, it is going to be the first item in our queue and the starting point to our algorithm. In our main method, we're going to add another variable called searching, and we're going to set it to true. This variable is going to help us interrupt the algorithm once the endpoint is found. Then we're going to create another variable called target box, and we're going to set it to none. This variable is simply going to store the box that we want to reach, so in other words, our target. Further below, we're going to start writing the logic that is required to run the pathfinding algorithm. We want the algorithm to start searching for a path whenever we press a key on our keyboard, and in addition to that, the target box has already been set. So this is where we have to set the begin search variable to true. Next, we're going to check if the length of the queue array is greater than 0 and if the searching variable is set to true. And remember that the very first box located in the queue is going to be the starting box, because that is the point from where the algorithm is going to start searching for the path. You can also see that we create a variable called current box and set it equal to queue pop and the index 0. What this does is that it sets the current box variable equal to the first box in the queue, and afterwards it gets rid of it from the queue. So every time we loop through this code, a box is removed from the queue array and its visited flag is set to true. Then we're going to add another if statement, which is going to check if the box taken out of the queue is equivalent to the target box, so if the end has already been reached. And if this condition does apply, so the current box is equal to the target box, then we want to set the variable searching to false, which interrupts the algorithm. If, however, the current box does not correspond to the target box that we want to get to, then this else statement that I've just inserted is going to be executed. And this else statement contains a for loop that iterates over all the neighbors of the current box. And if the neighbor has not yet been added to the queue and it is also not a wall box, then we want to do two things. First, we want to set the flag queue to true, and we also want to append this box to the queue. Then we add another else statement, which is going to account for the case where there is no solution. And if that is the case, we want to show a pop-up window which says that there is no solution. The final thing we need to do is we need to draw the boxes in the appropriate color. So if the box has been added to the queue, then we want to make it a red box. If, however, the box has been visited, then we want to make it green. So that's what the individual if statements over here do. They determine the color of the queued and the visited boxes. Now let's go ahead and see how far we've come by running this once. So of course, if I press my mouse down, I can go ahead and draw a wall, and then I can create a target block by pressing my right mouse. And then when I press a key, you can see that the algorithm runs, and the individual green boxes are the boxes which have been visited, and the red ones are the ones which are currently still in the queue but don't need to be visited anymore because the algorithm has already found the path to this yellow block. Okay, the very last thing that remains to be done is to draw the path that the algorithm has taken. So if we look at our nice diagram over here again, let's say we have a starting block which is in the top left corner. Let me make this a bit thicker. So let's say this is our starting block and we have an end block as well. So somehow we want to find a way in which we can display the route which the algorithm has taken. And this is exactly what we're going to do now. So over here in our editor, we are going to start by adding another empty array called path. And after we've done that, we're going to go down to our class box and we're going to add another variable called prior, and it's going to be set to none. Now, in order to understand what this prior is, I'm going to give you a really easy example. Let's go back to our diagram over here and let's zoom in. So at the very beginning, we have this one starting block, which is in our queue. And let's say that we have an end, which is going to be over here. So this is going to be the starting block. This is going to be the end block. They're really close to one another just because this is meant to be a simple example. So what's going to happen is that when this green block is in the queue, the neighbors of this block are going to be added to the queue as well. So this first block has been visited, the neighbors are added to the queue. Afterwards, the algorithm moves to the next box that's queued up in the queue. So we are going to go to this block, and it is going to be visited. The visited flag is going to be set to true as well over here. And after the visited flag has been set to true, we're also going to add the neighbors of this block, which we just colored in. And the neighbors are going to be this block over here, as well as our target block. So this target block is also queued. Now the algorithm proceeds by going to the item which was queued next, which is going to be this block. So this block is going to be visited as well. And its neighbors are going to be added. Since this block over here has already been added, we don't need to add it again. And it adds this one instead to the queue. Now it's going to get interesting because the next item queued is actually our endpoint. So the algorithm is going to visit this endpoint and detect that it is finished. So with all of this in mind, what exactly is the prior? It's easiest to understand this if we look at an example. So remember that this box right here came into the queue when this box over here was visited. So that means that the prior of this box on the right-hand side is going to be the one on the left. And so we can label it with the expression prior over here. We're going to use this concept of a prior to draw the path from the starting block to the end block. So let us go ahead and do that. To draw the path, we're going to need to make a change within the code of the algorithm. Over here is our algorithm, and we're going to add another small code block, which is going to be responsible for drawing the path from start to finish. In order to understand what's going on over here, let me go through this line by line. In this while loop, we're appending boxes to an array called path. And this array contains all the boxes that lie on the shortest path between the start point and the end point. So first, the endpoint is appended to the array, and then its prior is appended, and this process happens over and over again until we land at the starting box. The last thing that we need to do is we need to color the boxes that lie on the path between the starting point and the end point. So we're going to say that if a box is in the path, so if it is within this array called path, then we want to give this another color, and in this case it's going to be blue. So let's go ahead and now run this and see what happens. So you can see I have the starting block which is set. Now I'm going to add some sort of wall, and I'm going to set an end block. Now when I press the enter key, you can see the algorithm runs through, and in addition to that, it also draws a really nice path. So let's perhaps do that again with another example. Let's make it impossible to find a solution by surrounding the endpoint with a wall. You'll be able to see this dialog box pop up that there is no solution. And basically that is how you create this pathfinding algorithm. I hope this video has helped you out. If it did, then make sure to leave a like and subscribe to this channel, and I'll see you in the next video.